An operating system is the fundamental software that controls a computer. It acts as a bridge between the user and the hardware, allowing us to interact with the computer and run applications. Without an operating system, a computer would be nothing more than a collection of inert hardware. The operating system provides a platform for running other programs and manages the computer's resources, such as the processor, memory, and storage. Examples of operating systems include Microsoft Windows, macOS, and Linux. Operating systems are essential for any computer system, from small embedded systems to large servers. They provide a layer of abstraction that hides the complexity of the underlying hardware from users and applications. This allows users to interact with computers without needing to understand the intricacies of hardware design. Imagine a conductor leading an orchestra. The conductor doesn't play any instruments directly, but instead coordinates all the musicians to create a harmonious symphony. Similarly, the operating system manages all the different parts of a computer to ensure that everything works together smoothly. Just as a conductor manages musicians and their instruments, the operating system manages the computer's hardware and software resources. These resources include the central processing unit, memory, storage devices, input-output devices, and network connections. The operating system allocates these resources to different programs as needed, ensuring that each program has the resources it needs to run correctly. At the core of every operating system lies the kernel. The kernel is the most fundamental part of the operating system. It is responsible for managing the computer's resources and providing a platform for other programs to run on. The kernel is the first layer of software that runs on the computer, loaded directly by the BIOS during the boot process. The kernel interacts directly with the hardware, managing the CPU, memory, and other devices. It also provides services to other programs such as process management, memory allocation, and file system access. Think of the kernel as the engine of a car. It's the core component that makes everything else go. One of the kernel's primary responsibilities is to manage the computer's CPU. The CPU is the brain of the computer, executing instructions that make up computer programs. The kernel allocates CPU time to different programs, ensuring that each program gets a fair share of processing power. Another crucial role of the kernel is managing the computer's memory. Memory is where programs and data are stored while the computer is running. The kernel allocates memory to different programs and ensures that programs do not interfere with each other's memory space. A file system is a critical component of an operating system that provides a structured way to organize and store data on storage devices such as hard drives, SSDs, and USB drives. It defines how files are named, stored, and retrieved, allowing users and applications to access and manage their data efficiently. Imagine a library with thousands of books. Without a system for organizing these books, finding a specific book would be nearly impossible. A file system acts like the library's cataloging system, organizing files into a hierarchical structure of directories and files, making it easy to locate and manage data. A file system defines how data is organized on a storage device. It divides the storage space into blocks and uses a hierarchical structure to organize files and directories. The root directory is the top-level directory in the file system, and it contains other directories and files. Directories can contain other directories, creating a tree-like structure that allows for the organization of large amounts of data. Each file and directory in the file system has a unique name and attributes, such as its size, creation date, and permissions. These attributes provide information about the file and control who can access and modify it. The file system also keeps track of free space on the storage device, allowing for the creation of new files and directories. Process management is a core function of operating systems, responsible for managing the execution of multiple processes on the computer. A process is an instance of a program in execution. When you open a web browser, you create a new process. Similarly, when you edit a document, play a game, or run any other program, the operating system creates a new process for it. Think of a chef managing multiple dishes at the same time in a busy kitchen. Each dish represents a process, and the chef, like the operating system, must allocate resources, track progress, and ensure that all dishes are prepared efficiently without conflict. The operating system maintains a list of all running processes called the process table. Each entry in the process table contains information about a process, including its process ID, its current state, and the resources it is using. The operating system uses this information to manage the execution of processes and to ensure that they do not interfere with each other. One of the critical tasks of process management is to schedule processes for execution on the CPU. The operating system uses scheduling algorithms to determine which process should run next and for how long. Different scheduling algorithms have different goals, such as maximizing CPU utilization, minimizing response time, or ensuring fairness among processes. Section 5. Memory management, making the most of a limited resource. Memory management is another vital function of operating systems. It involves managing the computer's random access memory, or RAM, which is a valuable resource used to store data and instructions for running programs. The operating system must allocate memory to each process, protect processes from each other's memory spaces, and manage the swapping of data between RAM and secondary storage when RAM is full. Think of memory as a large whiteboard divided into sections. Each section can be allocated to a different process to store its data and instructions. The operating system acts as a manager, ensuring that each process has enough space on the whiteboard and that processes don't overwrite each other's work. When a process needs memory, it requests it from the operating system. The operating system then allocates a portion of memory to the process. The allocated memory becomes the process's address space, and the process can access and modify this memory as needed. Memory management is essential for ensuring that each process has enough memory to execute correctly and that processes do not interfere with each other's memory spaces. Without memory management, processes could overwrite each other's data, leading to crashes and data loss. Section 6. Hardware management, bridging software and physical components. Hardware management is a crucial aspect of operating systems, as it enables the operating system to interact with and control the various hardware components of the computer. This includes devices like the central processing unit, memory, storage devices, input-output devices, and network interfaces. The operating system communicates with these devices through drivers, which are software programs that act as translators between the operating system and the hardware. Think of hardware management as the conductor of an orchestra, coordinating the different instruments to create a harmonious symphony. The operating system acts as the conductor, managing the different hardware components to ensure they work together seamlessly. The operating system uses device drivers to communicate with each hardware device. A device driver is a software program specific to a particular hardware device. It understands the device's commands and translates them into a language the operating system can understand. The operating system loads the appropriate drivers for each hardware device during the boot process. Once the drivers are loaded, the operating system can communicate with the hardware devices and manage their operation. For example, when you save a file, the operating system uses the hard drive's device driver to send the file data to the hard drive for storage. Section 7. Security protecting the core. Security is a paramount concern in operating system design and implementation. A secure operating system protects the system and its users from various threats, including malware, unauthorized access, and data breaches. Security measures are implemented at different levels of the operating system to ensure the confidentiality, integrity, and availability of system resources and user data. Think of security as a castle protecting its inhabitants. The operating system acts as the castle walls, gates, and guards, protecting the computer system and its data from unauthorized access and attacks. One essential aspect of operating system security is user authentication. User authentication verifies the identity of users attempting to access the system. This is typically done using passwords, biometric authentication, or other authentication factors. By verifying user identities, the operating system can ensure that only authorized users can access the system and its resources. Another crucial security measure is access control. Access control mechanisms restrict access to system resources based on user privileges. The operating system maintains a list of users and their assigned privileges, which determine which files they can access, which programs they can execute, and which system settings they can modify. Section 8. Building from scratch. A monumental task. Building an operating system from scratch is a complex and challenging undertaking that requires in-depth knowledge of computer science, operating system principles, and low-level programming. It involves writing thousands of lines of code to create the kernel, file system, process manager, memory manager, device drivers, and other essential components of an operating system. Imagine building a skyscraper from the ground up. You need a strong foundation, a solid framework, and countless hours of work from skilled engineers and construction workers. Building an operating system is a similar endeavor, requiring meticulous planning, coding, testing, and debugging. The first step in building an operating system is to choose a suitable programming language. Operating systems are typically written in low-level languages like C or assembly language, providing direct access to hardware resources. These languages are more complex to work with than higher-level languages, but offer greater control over system hardware. Once a programming language is chosen, the next step is to design the operating system's architecture. This involves defining the different components of the operating system, their interactions, and the overall structure of the system. The architecture should be designed to be modular, maintainable, and extensible to accommodate future growth and changes. Section 9. Conclusion: the foundation of computing. Operating systems are the unsung heroes of the computing world. They work tirelessly behind the scenes, managing hardware resources, providing a platform for applications, and ensuring that everything runs smoothly. Understanding the basics of operating systems is essential for anyone who uses a computer, as it provides insight into how computers work and how to troubleshoot common problems. As we've explored in this essay, an operating system comprises many interconnected components, each playing a vital role in the system's overall functionality. From the kernel, the heart of the operating system, to file systems, process management, memory management, and hardware management, each component contributes to the seamless operation of our computers. As technology advances, operating systems continue to evolve, becoming more sophisticated and feature-rich. However, the fundamental principles of operating systems remain the same, providing a solid foundation for innovation and progress in the digital age. Understanding these principles is essential for anyone who wants to delve deeper into the world of computing and unlock its full potential.